Let's take an application for stoichiometry in terms of limiting reagents and percent yields. So be able to define limiting reagent. That's going to be the reactant that's going to end up determining how much product you can make in a reaction because it will be used up entirely. Percent yield, this is how much you actually make divided by how much you theoretically could be making. Theoretical yield is, well, how much you theoretically could make. So if the limiting reagent is used up entirely, you'll get a theoretical yield of a certain amount of grams. The actual yield is what actually happens, and it's usually less than the theoretical yield because, well, side reactions happen and incomplete reactions can happen. Be able to use stoichiometry to predict what the limiting reagent will be in a reaction. This is going to require molar ratios and using the masses. So yes, quite a bit of math. And calculate percent yield if given a theoretical and an actual yields of a chemical reaction. Again, this is math, but this is easy math. Let's look at this in terms of hot dogs. So hot dogs come in 10 packs and the buns come in 8 packs. So if you buy one thing of hot dogs and one thing of buns, you're going to be able to make 8 hot dogs with 2 dogs left over. I guess maybe carb-free dogs or dogs on a stick or something like that. So the yield is limited by the number of buns. So if you balance the equation for HD, meaning hot dog, 10 and BU, 8, the buns, making HD-BU, their 1-to-1 ratio, you're going to require 4 packages of hot dogs and 5 packages of buns to make 40 hot dogs. That's a lot of hot dogs. But you can see where limiting reagents and limited yield can come into play here. So a limiting reagent is a reactant that determines the amount of product that can be formed. If you only have so many screws or you only have so many bolts, then you can only do so much work. You're going to end up using up all of the screws if the screw is the limiting reagent and have bolts left over. That's how limiting reagents are going to work. So sample problem here from 12.8, you have copper 1 sulfide. It's the product of the reaction between copper and sulfur. So be able to write and balance the equation. So let's look at that. That would be 2 copper plus 1 sulfur is going to make Cu2S, so copper sulfide. Cool. And if you have 80 grams of copper and 15 grams of sulfur, which one's going to end up being the limiting reagent? Well, first off, 80 grams of copper is 1.26 moles of copper. 15 grams of sulfur is, I wrote 25 grams of sulfur there. Well, let's play with that for a bit. Is going to be 0.779 moles of sulfur. So using the 25 grams here. All right, so 1.26 moles of copper plus 1 mole of copper for every 2 moles of sulfur. So it's a 1-to-2 ratio is going to require 0.63 moles of sulfur. So it looks like we have more sulfur than is going to be needed. So copper is the limiting reagent there. So calculating yield, on the other hand, is an issue of looking at what you end up getting. So in the show Breaking Bad, Walter records the mass of methamphetamine produced each day. So the mass of meth is determined by, well, how much goes in and how much comes out. Now, Walter's not getting 100% yield. He never would. What would happen is there are going to be side reactions. They actually show the guys cleaning out the reaction vessels one day, and you can see there's some scum on there. That scum is going to be reducing the amount of meth that they're making. So if the yield starts changing over time, that could mean that one of the reaction vessels is becoming less efficient, in which case you might want to replace it or something. It could also, of course, mean that someone's getting stolen, which would be a problem. Spoilers. So yields. The theoretical yield is a maximum product that can be produced. Check those earlier equations. Your actual yield is the amount that's actually going to be made, and your percent yield is the actual divided by the theoretical times 100%. Your percent yield is going to measure how efficient a reaction is. The higher the percent yield, the more efficient a reaction is. And for large-scale industrial reactions, a higher percent yield can mean differences of thousands, if not millions, of dollars. So think about some things that could reduce percent yield. Again, side reactions could be going on. If you have too much oxygen present, some stuff could be oxidized. Some could be creating undesired products. The methamphetamine thing, fun fact, it actually makes 2 types of meth, L-meth and R-meth. It's something to do with chirality. It's actually talked about in episode 1, or early on, season 1 at least. So chiral reagents can cause problems there, chiral products. So there can be a lot of things besides human error reducing percent yield. Now let's look at this. Calcium carbonate can be decomposed into calcium oxide and carbon dioxide. What's the theoretical yield if you start with 24.8 grams of calcium carbonate? Well, clearly that's going to be the limiting reagent. It's the only reagent. So we don't need to really think about which is limiting, which is not in here. It's just you have one thing. So if you have 11.3 grams of calcium oxide are produced, what's the percent yield? So the theoretical yield is going to be 13.9 grams of calcium oxide. And if you have 11.3 grams made, 11.3 divided by 13.9 is going to be 81.29%.